Good day, everyone. Welcome to the continuation of our discussion on the topic application of differentiation. Today, we'll be treating more details on turning points, that's maximum and minimum. In our previous class, we went over the concept of turning points briefly, and we've stated that we have two types of turning point, that's maximum or minimum. And it was also stated that at turning points, the y over the s is equals to 0. That is, whether it is maximum or minimum, the y over the s will be equals to 0. It is very important to note that the number of turning points that our function has is the highest power of the function, that is the degree of the function, the highest degree of the function minus 1. So if we have a quadratic function where the highest degree is 2, the number of turning points will be 1. That is, if you ever have a maximum turning point or a minimum turning point. But for higher polynomial function with higher degree, the number of turning points will be the highest degree minus 1. So if the highest power in our function is 3, we will have 2 turning points. If the highest power in our function is 4, we have 3 turning points. Now, how do we differentiate between maximum and minimum? After concluding that our dy over dx equals to 0, to test if our turning point is maximum or minimum, we are going to be redifferentiating. That will be finding the square y over the x square. And if the square y over the x square is lesser than 0, the turning point is maximum. And if the square y over the x square is greater than 0, the turning point is minimum. Our very first question says that at what value of s is the function s squared plus s plus 1 minimum? Remember, since it's a quadratic function, we have just one turning point. And it's already stated in the question that the turning point is minimum. So the very first thing we are going to do is write down our equation y is equals to s squared plus s plus 1. And recall at turning point, that at minimum or maximum, the y over the s is equals to 0. So differentiating our equation, the y over the s will be equals to 2s plus 1. Now substituting the y over the s equals to 0 in our answer, 2s plus 1 will be equals to 0. Simplifying further, 2s will be equals to minus 1. And dividing both sides by 2, s will be equals to minus 1 over 2. And the correct answer is B. Our next question states that at what value of s is the function y equals to s squared minus 2s minus 3 minimum? Now the very first thing we are going to do is write down our equation y equals to s squared minus 2s minus 3. And since it's a quadratic equation, we have just one turning point, so there will be no need to test if it's minimum or maximum. And we know that at minimum or maximum, the y over the s is equals to 0. So differentiating our equation, the y over the s will be equals to 2s minus 2. So equating the y over the s will be equals to 0. 2s minus 2 will be equals to 0. Simplifying further, 2s will be equals to 2. And when we divide both sides by 2, s will be equals to 1. So the value of s when the function is minimum is 1. And our correct answer is A. Our next question states that a swimming pool is treated periodically to control harmful bacterial growth. The concentration of bacteria per cm cube after t days is given by the function c of t is equals to 30t squared minus 240t plus 500. In how many days after a treatment will the concentration be minimal? Now it's a question where we are looking for minimum point. At minimum point, the c over the t will be equals to 0. So our first call of duty is to differentiate our function. Differentiating, the c over the t will be equals to 60t minus 240. And since at minimum the c over the t equals to 0, we'll be substituting the c over the t to be equals to 0. Doing so, 60t minus 240 will be equals to 0. And simplifying, ct will be equals to 240. Next is to divide both sides by 60. 60 divided by 60 will be equals to 240 divided by 60. T will be equals to 4. Our next question is from November. It states that find the value at which the function s cubed minus 7s squared plus 15s has the greatest value. Now the first thing to note is the statement the greatest value is similar with the statement the maximum point. That is, the greatest value is the maximum point and the least value is the minimum point. So at greatest or least value, dy over dx is equals to 0, because at maximum or minimum, dy over dx is equals to 0. So writing down our equation, y is equals to s cubed minus 7s squared plus 15, and finding dy over dx, that is differentiating our function, it becomes dy over dx is equals to 3s squared minus 14s plus 15. Recall at maximum or minimum, dy over dx equals to 0. So substituting dy over dx will be equals to 0. 3s squared minus 14s plus 15 is equals to 0. At this point, to get the value of s, we are going to be solving the quadratic equation using factorization method. Now to factorize, we'll be looking for two factors in which when we multiply them, it's going to give us the product of a and c, which is 3 times 15, that's 45. And when we add them, it's going to give us b, that's minus 14. The two factors are minus 9 and minus 5. So splitting minus 14s into minus 9s and minus 5s, our equation becomes 3s squared minus 9s minus 5s plus 15 is equals to 0. Factorizing further, it becomes 3s in bracket s minus 9, s minus 3, minus 5 in bracket s minus 3 is equals to 0. And since the elements in our brackets are the same, you can factorize further to 3s minus 5 in bracket s minus 3 is equals to 0. At this point, 3s minus 5 will be equals to 0, or s minus 3 will be equals to 0. So therefore, s is equals to 5 over 3, or s is equals to 3. But at the greatest value, which is at our maximum, the square y over the s square is lesser than 0. So at this point, we are first going to find the square y over the s square by differentiating. Doing so, the square y over the s square will be equals to 6s minus 14. Since we've gotten the value of the square y over the s square, we are going to be testing the two values of s to see which one is going to be lesser than 0. When s equals to 5 over 3, the square y over the s square will be equals to 6 in bracket 5 over 3 minus 14, which should be equals to 30 over 3 minus 14. Simplifying the fraction, it becomes 30 minus 3 in bracket 14 all through divided by 3. And when we simplify further, that will be equals to minus 4, which is already lesser than 0. But let's test the other point for clarity. When s is equals to 3, the square y over the s square will be equals to 6 in bracket 3 minus 14, which when simplified will be equals to 4. So the square y over the s square at that point is greater than 0, which is our minimum point. Our next question states that find the value of s for which the function y equals to s cubed minus s has a minimum value. As usual, we are going to be writing down our equation y equals to s cubed minus s. And recall, at minimum or maximum, dy over the s is equals to 0. So differentiating, dy over the s will be equals to 3s squared minus 1. At this point, we are going to be equating dy over the s to be equals to 0. Now doing so, 3s squared minus 1 will be equals to 0. Simplifying further, 3s squared will be equals to 1. Dividing both sides by 3, s squared will be equals to 1 over 3. And finding the square root of both sides, s will be equals to plus or minus the square root of 1 over 3. So simplifying the square root, it will be equals to plus or minus the square root of 1 divided by the square root of 3. That is plus or minus 1 divided by the square root of 3. At this point, we are going to rationalize the solve. Rationalizing our solve, it will be equals to plus or minus the square root of 3 divided by 3. That is, it is either plus the square root of 3 divided by 3 or the square root minus the square root of 3 divided by 3. Recall that at minimum, the square y divided by the s square is greater than 0. So our very next step is to find the square y over the s square. Now differentiating our equation again, the square y over the s square will be equals to 6s. Now we are going to be testing which of the value is going to be greater than 0 for the square y over the s square. The first step we'll be using is when s is equals to the root 3 divided by 3. When s is equals to root 3 divided by 3, the square y over the s square will be equals to 6 times root 3 divided by 3, multiplying it to be equal to 2 root 3. And since this is greater than 0, this is our minimum point. But let's just test the other point, that is when s is equal to minus root 3 divided by 3. When s is equal to minus root 3 divided by 3, the square y over the s square is equals to 6 times minus root 3 divided by 3. Multiplying the square y divided by the s square is equals to minus 2 root 3. Since it is lesser than 0, this is our maximum point. And the answer we are looking for is our minimum point, which we got at the point where s is equals to root 3 divided by 3. So therefore, our answer is C. Our final question is from UME. It states that find the value of s for which the function f of s is equals to 2s cubed minus s squared minus 4s plus 4 as a maximum value. Now the very first thing we are going to do is to write down our equation. F of s is equals to 2s cubed minus s squared minus 4s plus 4. And recall, at minimum or maximum, f prime of s will be equals to 0. So differentiating our function, f prime of s is equals to 6s squared minus 2s minus 4. And since f prime of s is equals to 0, we are going to be equating 0 for f prime of s. Doing so, it becomes 6s squared minus 2s minus 4 equals to 0. At this step, we are going to be simplifying our quadratic equation by dividing all through by 2. And when we do so, the quadratic equation becomes 3s squared minus s minus 2 equals to 0. Now, to get the value of s, we are going to factorize. Now factorizing, we are going to be using factor method. And doing so, we are going to be looking for two factors in which we multiply them, which will give us the product of a and c. And when we add them, it is going to give us b. Our a is 3, our b is minus 1, and our c is minus 2. Now the two numbers which fit this criteria are minus 3 and plus 2, because minus 3 times plus 2 is going to give us minus 6, and minus 3 plus 2 is equals to minus 1. So splitting minus s into minus 3s and plus 2s, our quadratic equation becomes 3s squared minus 3s plus 2s minus 2 equals to 0. Factorizing further, it becomes 3s in bracket s minus 1 plus 2 in bracket s minus 1 equals to 0. Since the element in our bracket is the same, we can factorize further into 3s plus 2 in bracket s minus 1 in bracket equals to 0. At this point, 3s plus 2 will be equals to 0, or s minus 1 will be equals to 0. Simplifying 3s plus 2 equals to 0, it becomes 3s equals to minus 2. And dividing both sides by 3, it becomes s equals to minus 2 over 3. So therefore, our s is equals to minus 2 over 3, or s is equals to 1. But recall, at maximum, the square y over the s square is lesser than 0. That is, f prime of s should be lesser than 0. Now differentiating to get the square y over the s square, f prime of s, or the square y over the s square, is equals to 12s minus 2. At this point, we'll be substituting our value of s into f prime of s. We are going to be testing the two answers to see which one will be lesser than 0. Starting with when s equals to minus 2 over 3, we'll be substituting s for minus 2 over 3 in our answer for f prime of s, or the square y over the s square. Doing so, f prime of s will be equals to 12 in bracket minus 2 over 3 minus 2. Simplifying is equals to minus 10. And obviously, this fits our criteria because minus 10 is lesser than 0. So the function is maximum at the point s equals to minus 2 over 3. And the answer is C. Here are some exercises for you to try your hands on at home. The answers to these questions are found in our Hidden Facts Further Mathematics textbook. You can get the hard copy, or if you are interested in a soft copy, you can get it at the website at the bottom of the screen. Thank you.